All right, remember, this is one of those cumulative tests where you can take a retake on one of your previous tests. So if you got a C on one of your tests, for instance, and that's not you, you usually do better than that, you should know which one it was. Here's the one I just gave you back like yesterday. That was the third one. The first one we took was this one. It was pretty easy, but again, there was a few people that got kind of surprised low grades on that. So anyway, just know which one you might need to retake and make sure you've done the corrections on it. If you haven't done the corrections, you can ask me during work time today, and you can look these up on Skyward very easily. It's the last 3 tests we've taken. Other than, I think, 2-minute teacher thing is in there, the top 20. This obviously isn't pertaining to that, so skip that one in your head. All right, so what's on here? Well, the first section, the 4.1 to 4.3 quiz, that one is called Describing Graphs and Function Notation. Basically, I think I called it basic functions when I put it in the quiz. All right, and here are some practice problems for that. Would you sketch me out these 3 things? Decreasing at an increasing rate, increasing at a decreasing rate, and then just constant. It's very simple, very easy if you know what you're doing. If you don't, I want to catch it now so you can fix it. All right, well, decreasing, it obviously has to go down. What's wrong with that? That's a constant, and we didn't ask for that. Decreasing at an increasing rate, it has to, is that right? No, because it starts out fast and it ends up slower. The steeper is faster. So this starts out fast, and you can't really start out fast and then increase. That makes it tough. You got to start out slow and then go faster and faster. Raise your hand if you had that one right. Okay, good. The next one is increasing at a decreasing. Here's increasing at a decreasing rate. And the last one is constant, which would just be flat. It doesn't change. That's actually decreasing slightly. Sorry. I meant for that to be completely flat, straight across. Okay, on to the next topic, making a graph from a story. I will tell you a story. I want you to make me a graph for it. Billy gets on his bike and rides to the park, which is 7 miles away. He gets there after, let's say he's in a motorized bike because he's going really fast. So he gets to the park, which is 7 miles away, at about 5 minutes. Means he had to go over 60 miles an hour, which is why I was saying it wasn't on his bike. So anyway, now he stays at the park for about 5 minutes, realizes he left something at home, and drives back home. As he drives back home, he's going at a, starts out going fast, and then he goes slower and slower and slower. Eventually he gets home. And you can have him arrive home at any time you want. Yes, sir? That is a very good question. And you can't really do this graph unless you know that answer. You can do it until the end, but then that last part you'd have to know, is this a total distance graph or is this a distance from home graph? And this is a distance from home graph. Because if it was total distance, then his total distance would increase the whole time. He couldn't like decrease his total distance traveled. That doesn't make sense. He'd have to go back in time somehow. So this is distance from home. All right. If I said the park was 7 miles away and he did it in 5 minutes, do you get, if this is in minutes down here, that 5 minutes he has to hit 7? You should have hit that spot. Raise your hand if you did. Okay, good. You had to be at that spot. You can't just freehand this. Next, how he got there, I wasn't real specific about whether he rode at a steady rate or he rode at an increasing or a decreasing. So you'd have lots of options. Would you agree that in the real world it's really hard to actually go the exact same rate the entire time? It is. It's tough to go from 0 to 60 miles an hour instantaneously, for instance. Okay, so I would say it's more reasonable if you're given a choice to maybe do an increasing at an increasing rate, kind of like that. Then, constant would have been fine. Would be really kind of weird to be like this in the real world. You're not likely to be able to go super fast, then slow down from there. Instant super fast stuff. All right, it said he stayed there about 5 minutes. 1, 2, 3, 4, 5. Now you could debate about if he's actually moving at the park. If you're talking total distance would probably be going up if he was moving at all at the park. We aren't doing total distance. We're doing distance from home. And then he got back home. And this part, I did say he went kind of fast at the beginning, and then he went slower and slower. That should mean something like that. And it could have ended anywhere because I didn't say when exactly he got home. Raise your hand if you understand that. Okay, good. Let's move on to the next kind. Finding f of negative 3 when given a graph or an equation. All right, let's say they give you this and they ask you for f of negative 3. Can you handle that? Go ahead, try it. Stick the number in, see what you get. Don't just ponder. Only do you should use the pencil. Or stylus, or finger. All right, f of negative 3. So you want me to put in x is negative 3. All right, so 2 empty spot squared plus 5 empty spot. I really recommend this method. Put empty spots with parentheses. It's coming up in pre-calc all the time that I'm teaching right now in my other classes. That if they don't put it in a parenthesis, it a lot of times will screw up the answer. And when you have a situation like this, where you're sticking in negative 3, did you know that if you have a negative 3 squared without the parentheses, that the 3 will get squared and then the answer becomes negative? So the answer for this would be negative 9. Where it was supposed to be like this, where the answer is going to be positive 9. So those parentheses do matter. Okay, so not only is it helpful, it helps you get the right answer. Okay, so that's 9 times 2 makes 18. 18 plus negative 15 makes total of 3. Raise your hand if you got 3. Okay, good. Now I'm going to make it a little bit more complicated. They could ask you to find 3f of negative 3. Don't go to all the work of refiguring out f of negative 3. You already know what f of negative 3 is. What was f of negative 3 again? 3. And so now it's 3 times replace this whole thing with what? 3. So the answer is 9. You get that? Okay, so notice when you're doing this, you start by figuring this out, and then you do this other thing to it. All right, now take a look at this picture and tell me what f of negative 3 is. F of negative 3. You have to ask yourself, when they give you f of negative 3, did they give you an x or did they give you a y? They give you an x. They said x is negative 3, and you got to find on the graph, where's x? Negative 3. X is negative 1, x is negative 2, x is negative 3 right there. So what is the y at that spot? 0, so the answer would be 0. If they asked for f of negative 3 on this graph, lift up my negative, sorry, the answer would be, what's the y? Because they told you x is negative 3. What's the y there? 0. All right, let's make it a little more complicated. What if it's f of 1? Just what's f of 1? What's the answer? Here's x is 1. Follow it down. Negative 2. So what if they had asked you for 6f of 1? Go 6 times, what's f of negative 1? Or sorry, what's f of 1? Negative 2. And you do 6 times negative 2, and the answer would be negative 12. Okay. All right, let's move on. Next kind. This is weird. Why are those selected? I can't. Okay. 4.1 to 4.3, describing graphs, finding x when f of x is negative 1. Ooh, wait a minute, that's different. That's not f of negative 1. That's f of x is negative 1. So, what's different about it? They gave you the y. Look, it's x is still an x. They did not tell you the x. They told you the y. They told you y was negative 1. Let's find where y is negative 1. Here's where the y things are, and here's where y is -1 right there. Follow it across like this. Oh, there it is. What's the answer? 8. X must equal 8. Let me give you another one like that. Let's say, this is more tricky now. What if f of x was equal to 1? And a lot of people are going to get it wrong because they're going to say this. Oh, it's 0. That's wrong. Why is it wrong? Yes. Because there's 2 other answers. 0 and keep going. This is a line all the way across here. It's got 3 ways you can have y be 1. See, they told you y is 1, and there's 3 ways. X equals 0 is one of them. X equals 4 is one of them. And the last one is probably a 7.5 or 7 2/3 or something like that. I wouldn't make you, don't worry, it won't be that tricky to figure out. I'm going to go with 7 2/3 because I think that's what it is. If we actually do the math on it, because it's dropping from here to here. No, it's actually a half. I got lucky. Okay. Do you see how there's 3 answers to that? It's because the y line is at 1. I go right across here where y is 1. Here's where y is 1 right there. But I go across there, and all those things are x's that go with a y of 1. All right, moving on. Finding f of g of x. You guys try this one. Find f of g of x. Put the g into the f. All you have to do is write it out. Don't multiply it all out and everything. Just figure out what it is. Okay, here's what you should have had. You're putting the g into the f. That's this one is going to go into that one, and the only place it can actually go into is the x. So I go 6 empty spot squared minus 8. Notice me writing it out with an empty spot where the x is. Very handy. Now I'm going to drop in the x minus 4, and I am done. That is f of g of x. To be safest, I should probably write y equals. Or I could write f of g of x equals. But I really shouldn't just have it without a equation. Although it never said I had to give an equation, so I would have been okay. The directions didn't say to give an equation. All right, moving on. Translations and reflections. This kind, you're going to be taking a graph or a equation like this and then naming the order that you should do the problems in. Give me a 1, 2, 3, 4, 5, and tell me what should be done and in what order. Things like left, right, flip is not okay. Alex, you're not doing math. Get to it. Number these from 1 to 5. Okay. Where have I told you to start? Inside or outside? Inside is correct. If I go on the inside here, which one is normally first? And this one really confuses people because they go, oh, multiply and add. Well, multiply comes first. That's not the right question. It's not multiply versus add. It's multiply versus what? Parentheses. And if parentheses are really what you're choosing between, parentheses or multiply, don't parentheses normally go first? And so therefore they do not go first. All right, so the 3 should be first. And you should have done vertical, stretch, factor. No, I'm wrong, not vertical. Vertical, not vertical at all. What is it? Horizontal. And is it a stretch? Shrink. Factor 1/3. Question on that? All right, because it's on the inside, it does the opposite of what you think. It seems like 3 times wider. It's actually 1/3 as wide. And then the other thing is the 6, and that is what you'd think, 6 to the left. Then on the outside, once we get to the outside, there is these two or the 9. Well, these two are both multiplies, so they should be first. And on the outside, we obey the order of operations. And so we multiply by the 2 or the negative, and I recommend you stretch before you flip. So I'm going to do the stretch. So that's a vertical stretch factor 2. Now, it would have been okay if you'd have started with the other one, though. You could have done the flip first. Can't officially call it a flip. It's an up-down. It's a reflection over the x. And the last thing we do is the 9, and that's up 9. Did anybody, without my help, have it in perfect order? All right, that's only about half of you, and that's kind of what I expected. Deceivingly difficult question when only half of you got it right. Okay, so be careful on those. Question?
I'm kind of confused on like the graph, how you tell if it's both reflects over the x and the y.
If we had given you a graph,
Stretch and like vertical and horizontal.
yep, I know what you mean. This kind, where there's 2 numbers, one on the outside. I know what you mean. We would not do that to you on a test. There's either going to be something on the inside, something on the outside, but not both. So don't worry. That I know there was one like that on the homework, and I don't even think the answer was correct as it was. It wasn't supposed to be both. You're going to only have to do one or the other. Don't worry about that kind. Here is one like that, and this graph f of x, that's this little hat thing, or whatever it is been moved and flipped and all that stuff. Okay, if you're given a graph like this, you'd have to give the equation that would get you from here to here. Okay, so the first thought is you don't know what the function is, so it's going to have f's in it, and it's going to, of course, have an x in it. And then it just becomes a matter of, did this get stretched at all, or does it seem to you like it's the same size? I agree. No stretching. And besides, we're in the translations and reflections part. So do you agree that it got moved? Is it just simply moved to the left? No. It's also what? It's reflected. It's reflected over the y. Okay, so how do I do a reflection over the y-axis? Is that a negative on the inside or the outside? Inside. You have a negative on the inside. Would you finish it, please? I'm going to draw this with darker marker here. One little thing wrong. Okay. So first, if you flip it, I hope you get that it looks something like this after you flip it. Something like that. And then you got your hat thing that goes out to the 8, so like that-ish. Do you get that that's the flip? The left-right flip? And then where is it going from there? Pretty much down. How much down? 4. So if I go down 4, how am I going to make that go down 4? On the outside or the inside? Is that it? Did it move left or right? Nope. Once it got flipped, it didn't move left or right. It just moved straight down. Okay? Any other questions on that? All right. Let's try another one. This one has been moved, and tell the equation that changes the one to the other. Say that again. Oh yeah, I should do domain and range. I'll do domain and range of this one. Sorry, I forgot about that other one. So when you're doing domain and range, do it of the second one. All right. So you should have said an equation. Notice it says equation. I'm going to start with y equals. That's the safest thing to do anytime they ask for an equation. F of, and then which way does it get flipped? Up, down, or left, right? Up, down, and so that is that on the outside or the inside? Outside. So it's a negative on the outside, and then you have the x in here, and then is it moved left or right? No. Has it moved up or down? How far down? Down 1. There it is. Negative on the outside, f of x minus 1. Like that. And you need a y equals because it said equation. Those little half points add up. Try not to lose those. Okay, now domain and range. Domain is left to right. How far left does this thing go? -8. To how far right does it go? 0 is correct. Brackets because it touches them. And then the range. How low does it go? -5. To how high does it go? That's exactly right. Raise your hand if you had that one right too. Awesome. And we're most of the way there. Not done yet, but we're getting close. Given a function, f of blah, 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 and then if f of x is x squared, all right, a lot of people mess these up on the test. I was surprised somebody messed these up on the regular test. So if you have this function and then they tell you that the f of x is x squared, they're telling you the parent function was squared. What part of this gets squared then? The x minus 5 part gets squared. Why not the whole thing? Because this f is really only in charge of what is in parentheses after it. That extra plus or 4 at the end is just a extra plus 4. F is only in charge of this. It's gonna do that to this. So really I can just go like this. X minus 5 quantity squared plus 4. And I'm going to write y equals, even though it didn't say I had to write an equation for it. And then it wants me to graph it. So now do you know how to graph that? Let's say that you go blank. What will always save you? XY chart. I mean, if you go completely blank, you won't think of the XY chart either. But, okay, if you're like, I can't remember which function this is. Is this the V? Is this the U? Is this the S shape? Which one is this? So, you make a little chart and you pick some numbers. So I'm going to say, let's put in 5. Do you know why I picked 5? Because then I can make this 0 and it makes it really easy. 0 plus 4 makes 4. 5 comma 4 is on my graph. Over 5, up 4, dot. I'm pick another number. Let's say 6. That way 6 minus 5 will give me 1. 1 squared is 1. 1 plus 4 is 5. 6 comma 5. 6 comma 5. It's really hard to tell where the graph is from this. I mean, it still could be a V shape. It still could be a U shape. I don't exactly know. But if I just keep picking points, eventually it'll show me. 7. So 7 in here. 7 5 is 2. 2 squared is 4. 4 plus 4 is 8. 7 comma 8. 7 comma 8. Oh, it's starting to look like sort of part of a parabola. I'm putting in 4 and see what happens. Put in a 4. 4 minus 5 is -1. -1 squared is 1. 1 plus 5 is 1 plus 4 is 5. 4 comma 5. It is going to be a parabola, I think. I'm going to try one more. I'm going to put in a 3, and I'll go 3 minus 5 is -2 squared, which is 4. 4 plus 4 is 8. 3 comma 8. Yeah, I'm starting to see the symmetry there. It's obviously a parabola, and there I go. Now, do you get that a kid could have very easily like moved this down 5 just by dumb mistake? And this would have caught you. The XY chart would have kept you from making that mistake. Too often people are just over quick to like, oh, I see, it's down 5 and left 4, and they got them backwards or something. All right. Stretches and shrinks, the last test, the most recent test. Here's one that has been shrunk. Try to figure out what happened. Now, I gave you an extra hard one that we wouldn't have anything this hard in the test, but see if you can handle it. The good part is it doesn't have any left-right moves. Write it down. And we're getting to the part where it's hard to stay paying attention, but we're almost done. Just a couple more minutes. Equation. Y equals. Then, to get the g of x from f of x, it got smaller, and again, it got flipped. It got flipped left, right. So I'm going to go like this. Here's my f of x, and then it got flipped left, right. That's on the inside. You agree with that? Okay, good. Next part, didn't move up or down. It just got half as tall. You get how I can tell that? This height here used to be 4, and here it only goes up to 2. Half as tall. How do I do that? Half on the outside. Very good. And then it got, look at this. It used to be how wide? 8. And now how wide is it? 4. It got half as wide. So you don't put a half on the inside. Put a 2 on the inside. We already had the negative there, so don't forget that. And I just told you we probably wouldn't do anything on the test that's got 2 things like that. So that was extra tough. But how many of you figured it out, though? Raise your hand if you had it. All right, good. Moving on. Here's 2 functions, f of x and g of x. Graph f of g of x. Well, it sounds complicated, but it's really not that bad. Just stick the one function and the other function. You know what the new function is. And then just do a quick sketch of this thing. I don't want to spend too much time on it. G's on the inside, see? So G goes in the other one. This one goes into this one, x minus 4. There we go. And so basically this is a parabola that has been, if I'm going to start on the inside, it's been moved 4 to the right. So here's a parabola. It's just a sketch. 4 to the right. And then what's that minus 8 going to do? Down 8. But shouldn't I stretch it first? Yeah, I should. I should stretch it and make it twice as tall. Now, I know I said to do a sketch, so I'm not expecting it to be perfect. But basically, it's like you grab the red one, pull it up, it's going to make it stretch like that. And then I go down 8. About like that. Raise your hand if yours is in the right general area. Okay, good. Then, this is if you had an official graph to do like this. I know it's a V shape. And I generally know where it is, but this is not a sketch. If this was a true graph problem, I would probably try to do it this way. I'd probably try to move it to the right too. Here's my V now. Then I'd try to move it, make it 3 times taller. That can be tricky, but this is up 1. I'm going to make it up 3 instead. And same with that. And now my new V is much steeper. And then I would move it down 8. So what would I do to check myself? XY chart. And if I just check a few points, I can make sure I didn't screw something up. What's a good point to check? What's the perfect number to pick here? 2. Now why 2? Because when I put in a 2, I get a 0 in there, and it makes most of the thing cancel out, and it's just 8. 2, negative 8. So if I go to 2, negative 8, you see that I don't know, it's off the screen a little bit, but there. And I shifted it a little too far because it was off the screen. There we go. So already my XY chart made me make a little correction to make sure I did it right. Okay, so 2, negative 8's on my graph. It's right there. If I check one more point to make sure, I'm going to check, let's say, 3. 3 minus 2 is 1. Absolute value is 1 times 3 is 3. 3 minus 8 makes negative 5. 3 comma negative 5 should be on there. And, ooh, I was off a little bit. See that? All right, so checking it with your XY chart can be much better than just trying to freehand it. All right, last one. Write an equation from a description. I'm just going to read this to you. You see if you can write the equation. I'll give you a hint. It's an equation. How are you going to start? Y equals, okay? It's an absolute value function. Write the new equation you'd need in order to accomplish a vertical stretch of 4, a horizontal shrink of 5, actually I should have said 1/5, sorry. Translation to the right of 7, and down 8, and lastly a reflection over the x-axis. This is not necessarily in any order, but these are all the pieces you'd need. I'll say it again. Vertical stretch of 4, horizontal shrink of 5, translation to the right of 7, down 8, and a reflection over the x. This should have been a 1/5. Sorry about that. All right, so here's what you should have done. Y equals, and you got an absolute value and an x, and I'm leaving lots of space so I can stick stuff in there. And then it's a vertical stretch of 4. 4 goes on the outside. Horizontal shrink of 5. Is it a 5 on the inside or a 1/5? It is a 5. If I wanted to shrink, I use a big number on the inside. Right 7, down 8, and reflection over the x-axis. And what mistake did I make? This is all, like 1/3 of you made this mistake on the test. Yes, sir? You got it. Where? If you don't have that parentheses there, it will not work. It wouldn't go where you think it would go. Be honest, how many of you had the parentheses in there? Yeah, only like 4 of you. Okay, so be careful with that. Okay, and that is it. We covered everything that you would need to know for the test for tomorrow. And I'm going to give you your assignment, which is that review. But since I have done a lot of problems with you in class, I am going to cut it down for you.